All right, welcome to Transition Math. I hope you're enjoying a warm, cozy morning. This is exactly what I didn't want to be doing. This is going to be lesson 5-5, which in my opinion is the most important lesson probably this whole year for you. Now, notice I didn't say the hardest lesson, so it's not difficult per se, maybe different, but it is the most important that is going to help you. If you understand this, it's going to help you in future math classes. So if you have this handout, it says Transition Math Lesson 5-4 through 5-5. Please get that out. If not, let me know if it's not already posted on NGrade. Go ahead and let me know. We already did the fact triangles. We did that last time we met. And then the next page is what we need to get to the heart of the matter here. So we are going to solve equations x plus a equals b. And we're going to solve for x. So a and b are going to be numbers, and we are going to be able to solve for x. Some of these we can do in our head. Right, Jackie? And so why do we have to do this? Because sometimes we can't, and they're going to make it so that you won't be able to just figure it out in your head. So the first thing on this first line, it says the addition property of equality. If a equals b, if a and b are the same thing, they could be 3 equals 3, or it could be 3 plus 1 equals 2 plus 2. If a equals b, then a plus c equals b plus what? Well, it kind of makes sense that if a equals b, and if I add this c to a, then I can add that same number to b, and it will still equal itself. They will equal each other. So let's say, let's just pick, 3 equals 3. Well, that is, we can pick, for c, we can put a 1 in there. Then that means 3 plus 1 equals 3 plus 1. 4 equals 4. It checks out. Well, this idea is going to help us solve any of these equations, okay? And that's what's super important. So, it means we can add the same number to both sides of an equation and it will still be equal. And examples, I gave an example there, I put 5 equals 5. Up here I put 3 equals 3. And so then you can add a number n plus 5 equals 5 plus n. All right, so let's just take, what I did was I pulled out some easy examples that we can do in our heads, but we're going to use algebra to do them so that we can see when things get a little bit more difficult and we can't do it in our heads, we can still use algebra to do them. So let me write these guys down. You have them on your paper. X minus 7 equals 17. All right. So this guy right here, x plus 6 equals 10. You can tell me right now that x equals 4, right? I hope so. But let's do it algebraically. We know from this addition property of equality, and it actually follows that you can also subtract the same number from both sides. So what we are our goal in life as pre-algebra students is going to be that we are going to get x by itself, okay? And what we have right here is this x is not by itself. It has an annoying plus 6 next to it. So what we're going to start learning is that to get rid of this plus 6, we're going to do the opposite of plus 6 to get rid of it. So bear with me. What if I subtract 6 from this side? And now notice I'm going down because that's kind of a standard and it makes things a little bit neater. So just so we can do that. Okay? So if I have x plus 6 minus 6, what does plus 6 minus 6 equal? Well, hopefully you're like, it's really easy. This is going to equal 0, right? 6 minus 6. So remember, we have to add or subtract the same number from both sides. So I'm going to subtract this 6 from both sides, not just this side, both sides of the equal sign. So now on this side I have 10 minus 6. 10 minus 6 is 4. What do I have on this side? I have x plus 0 equals 4. Well, x plus 0 is the same as x. X equals 4. And remember, that's what we said that equals. This looks like a lot of work to figure that out, but I'm kind of stepping through so that it'll help you later on.